The concept of today is about area in Euclidean geometry, which mean in a two-dimensional space. So in our figures we'll use color to illustrate area. So let's start out with the definition. The area is the surface occupied by an object on a two-dimensional plane. The area is calculated in square units. So as you can see on the right figure, you can see a square, and on the left figure, you see the same square, but it's colored in purple to illustrate the area. Let's have a look at some concrete application. If you want to buy some window and want to have a price estimation, then having the area of this window would be useful because the price is often per square centimeters. If you want to paint some walls inside your house and you want to buy some paint, well, to be able to paint this wall, you have to have a good quantity of paint. So this is directly related to the area of the walls. And then finally, if you wish to install some grass on your field, then you would need to have a good quantity of grass to cover the area of your field. So now we have an intuition about what is the area, but we are not familiar yet with its properties. So let's check them out. So first we have that the area of a bounded surface is positive or equal to 0. Then as a second property, given a chosen unit length, the area of a square of side 1 is equal to 1. The area is additive. And finally, we have the fourth property. The area is invariant to translation and rotations. Let's see an example of property 1 in order to have a better intuition. So the property 1 is about positive area. Here we say positive because it's greater or equal to 0. So consider the following square of side length equal to c, where c is greater than 0. Then as you can see, we have some area in this square. So now if you try to shrink down c, you can see that the area is still defined. It's just becoming smaller and smaller, but it is still a positive area. So property 2 is about the basic figure, which is the unit square of side 1. Each of the sides of this square is of length 1, and it turns out that the area of this square is 1 unit square. So when you're interested into the area of a general figure, you're trying to see how many of these square units you can fit inside your general figure. The third property about area additivity. So basically the idea is that if you have a figure, you can split it into disjoint area, and the sum of these disjoint area is the area of your total figure. So here, for example, you have a square of side 3 by 3, and then you can just split it in different small squares, and then you can just sum these squares to get the total area of the original figure. So the fourth property is about invariance to translations. So the idea is that the area does not vary even if you apply some translations. So for example, if you check this figure, even if you move the square, the area remains the same. So it really makes sense if you think about it. If you have a tile in the floor of your kitchen, even if you remove this tile, it covers the same area on your floor. So the fourth property also concerns invariance to rotations. So again, we take the same figure, and then now we try to see if there is some effects if we try to apply rotation to it. So by applying rotation to this figure, you can notice that the area remains the same. So basically, even if you apply rotation, the area remains the same. So it also makes some sense if you think about it. If you have a tile in your kitchen, even if you rotate the tile, it keeps covering the same area of the floor. Let's have a small recap of this lesson. So it's important to remember first that these properties and things that we just saw apply to all kinds of figures, and it's not limited to square and rectangles. So first, the area is the surface occupied by an object on a two-dimensional plane. The area is calculated in square units. So these are part of the definition that we mentioned earlier. And then the area of a bounded surface is positive. Given a unit length, the area of a square of side 1 is equal to 1. The area is additive. And finally, for the last property, the area is invariant to translations and rotations. So this is the end of our lesson. Thank you all.